The man who won the Nobel Prize for solving protein folding just sat down with Y Combinator and dropped his AGI timeline 2030. Demis Hassabis, chess prodigy, neuroscientist, founder of DeepMind, creator of AlphaFold and AlphaGo. He revealed what's still missing for AGI, why engineers are becoming 1000x more productive, and his advice for anyone building with AI right now. This is the most important 12 minutes you'll watch today. What's still missing for AGI? Hassabis says the current paradigm, pre training, RLHF chain of thought, will definitely be part of the final architecture. He's certain this isn't a dead end, but there are one or two things still unsolved. Number one, memory. Right now, we shove everything into the context window. That's brute force. The brain handles this with the hippocampus, replaying important episodes during sleep to integrate new knowledge. AI doesn't do this yet. Number two, continual learning. Models can't adapt to new contexts on the fly. Number three, consistent long term reasoning. Models still fail at things a smart undergrad wouldn't. His bet, 50-50, whether we need entirely new ideas or just better scaling of what we have. Here's something most people don't realize. AlphaGo's techniques are directly shaping Gemini today. All the thinking modes, chain of thought reasoning, Monte Carlo tree search. These are AlphaGo ideas coming back at scale. Hassabis said reinforcement learning is potentially still underrated. DeepMind has been building agent systems since day one. Atari, AlphaGo, AlphaStar, StarCraft. The question was always, can you generalize game playing models into world models and language models? That's what the last few years have been about. And he says the biggest advances in the next few years will come from reapplying these old AlphaGo and AlphaZero ideas to today's foundation models. Why are smaller models getting so powerful? Google invented distillation. They take their biggest frontier models and pack that intelligence into tiny models, flash models that are 95% as good at 1/10 the cost. Hassabis sees no theoretical limit to how smart small models can get. A year after a frontier model launches, that same capability will be in edge sized models. And this unlocks everything: speed for iteration, privacy for sensitive data, local models for robotics. He envisions a world where powerful local models handle audio and video on device, only calling the cloud when needed. The Gemma 4 open models are already showing this frontier class power in tiny packages. The 1000x engineer is real. Gary Tan said engineers at Y Combinator startups are doing 1,000 times the work of a Google engineer from the 2000s. 1,000 times. Hassabis confirmed this matches what he's seeing. Small models make this possible because you can iterate incredibly fast. Even if a model is only 90-95% as good as the frontier, you gain back more than that 10% through iteration speed. The bottleneck isn't intelligence anymore, it's how fast you can loop. And when inference gets cheap enough for millions of agents working in swarms, that changes everything about what a single engineer can build. Are agents overhyped? Hasabi says we're just getting started. The reason agents aren't fully autonomous yet is the lack of continual learning. They're useful for parts of tasks, but they can't adapt to context the way a human does. Once we crack continual learning, agents become fire and forget. You assign them a problem, They figure it out themselves. They learn from the specific context they're in. That's the missing piece. And Hassabis believes we have to crack this for full general intelligence. It's not optional, it's required for AGI. Can AI become truly creative? This is where it gets fascinating. Hassabis uses what he calls the Einstein test. Take the knowledge available in 1901. Can a model independently derive what Einstein discovered in 1905? Special relativity, the photoelectric effect. That's not pattern matching. That's genuine creative reasoning, analogical thinking, going beyond the bounds of what's known. He says current models can't do this yet, but he doesn't think it's magical. One or two missing pieces. And once AI passes this test, once it can generate truly novel hypotheses, not just solve existing ones, that's when science explodes. AlphaFold changed biology forever. Over 3 million researchers worldwide use it. Every drug discovered from now on will have used AlphaFold at some point. They gave it away free to every scientist on Earth. But Hassabis says it's just the beginning. The pattern for AlphaFold style breakthroughs: massive combinatorial search space, a clear objective function you can optimize against, and enough data or a simulator to generate training examples. If those three conditions are met, today's AI methods can find the needle in the haystack. Whether that's the perfect go move, the right protein structure, or the compound that cures a disease. The next frontier, a virtual cell, a complete working simulation of a cell that you can perturb and predict outcomes. Skip expensive lab experiments, generate synthetic data, train models that predict real biology. Hassabis estimates we are about 10 years away. They're starting with the cell nucleus because it's self contained. The bottleneck isn't compute, it's data. If we could image a live cell at nanometer resolution without killing it, the problem becomes a vision problem, which AI knows how to solve. Materials science, drug discovery, climate modeling, mathematics. He sees AlphaFold moments coming for all of them within the next few years. Hassabis' advice for founders: find the intersection of AI and deep technology. Materials, medicine, biology, hard science. If it involves the world of atoms, not just bits, you're safer from being disrupted by the next foundation model update. The most defensible companies combine AI expertise with deep domain knowledge. Either be an expert in both or build a founding team that covers both. Nothing worth building is easy. And the people who build truly lasting things work on problems they'd pursue regardless of the outcome. He worked on AI for 30 years, through decades when investors said it would never work. The AGI timeline question. Hasabi says around 2030. That means if you're starting a deep tech company today, a 10-year journey, AGI appears in the middle. You have to account for that. Not as a threat, but as a tool. The future architecture won't be one giant brain. It'll be general purpose models, like Gemini using specialized tools like AlphaFold. The general model orchestrates, the specialized models execute. Build something that AGI will want to use as a tool. Build something that creates value in the world of atoms. That's the play. A Nobel Prize winner just told you AGI is coming by 2030. Smaller models will keep getting smarter with no theoretical limit. And the 1000x engineer is already here. The question isn't whether this changes everything, it's whether you're ready. Subscribe for more deep dives like this. Comment DeepMind for the full cheat sheet. And if this changed your perspective, smash that like button.